Everyone, welcome to Points of Pharma. Today, the topic is iodine value. Iodine value is the expression of degree of unsaturation present in the sample of oil or fat. Begin with chemical nature of oil and fats. Chemically, oil and fats are triglyceride. It means the oil and fat have three long chain of fatty acid esterified with glycerol. Most natural fat and oils are mixed triglyceride. Mixed triglyceride means all the three fatty acids present in the triglyceride are usually not identical. The triglycerides are classified as saturated glyceride and unsaturated glyceride on the basis of absence and presence of double bond. Saturated glyceride are the glyceride where the component fatty acids have no double bond, whereas the unsaturated glyceride are the glyceride where the component fatty acids have one or more double bonds. To the unsaturation in the glyceride and their reaction with iodine. The unsaturated glyceride on treatment with iodine in the presence of a catalyst such as mercury chloride give diiodide. The diiodide is formed by the addition of iodine at the double bond in the acid component. Here the point to be noted is that the quantity of iodine consumed is proportional to the number of double bond, and this reaction of iodine with unsaturated glyceride is used to determine the number of unsaturation in a given sample of fat or oil, and it is expressed as iodine value. To iodine value. Iodine value is the weight of iodine absorbed by 100 parts by weight of fat or oil under certain specified condition. Under certain specified condition, because the iodine itself is not absorbed from a simple solution by unsaturated glyceride to an extent equivalent to complete saturation of double bond. And so, the determination of iodine value is not so straightforward as might be imagined. Now, coming to the method for the determination of iodine value, there are three pharmacopoeial methods for the determination of iodine value. The first one is iodine monochloride method. The second one is iodine monobromide method, and the third one is pyridine bromide method. Iodine monochloride method, which is also called Wijs method. The principle of this method is that the sample is treated in carbon tetrachloride medium with known excess of iodine monochloride solution in glacial acetic acid. The excess of iodine monochloride is then treated with potassium iodide to liberate the iodine, and finally the liberated iodine is estimated by titration with sodium thiosulfate solution. The reagent required here are iodine monochloride solution, carbon tetrachloride, potassium iodide solution, 0.1 m sodium thiosulfate solution, and starch indicator. The apparatus here include iodine flask, burette, and pipette. As the name itself indicates, here the iodine monochloride solution is the very important reagent. Iodine monochloride solution. The molecular formula of iodine monochloride is ICl, and iodine monochloride solution in fact is ICl in a mixture of carbon tetrachloride and glacial acetic acid. It is prepared by reacting iodine trichloride in glacial acetic acid with a known quantity of iodine in carbon tetrachloride, and then diluting the medium with glacial acetic acid to the desired volume. The quantity required for the preparation of 100,000 ml of iodine monochloride solution include iodine trichloride 8 gram, iodine 9 gram, carbon tetrachloride 300 ml, and glacial acetic acid QS 2000 ml. The iodine monochloride solution should be kept in a stoppered bottle, protected from light and stored in cool place. Coming to the procedure for iodine monochloride method for the determination of iodine value. First of all, weigh the sample accurately in dry iodine flask. Now here the point is how much quantity of sample is required. In fact, the quantity of sample depend upon the expected iodine value. And in general, for iodine monochloride method, the weight of sample is equal to expected iodine value divided 20. To the sample, now add carbon tetrachloride 10 ml and dissolve. Then add 20 ml of iodine monochloride solution and insert the stopper to the flask after wetting with potassium iodide solution. Now keep the flask in dark place at a temperature between 15 to 25 degrees centigrade for 30 minutes. Then add potassium iodide solution 5 ml first in the cup top of iodine flask and then carefully remove the stopper. Rinse the stopper and side of the flask with 100 ml of water. Shake the reaction mixture and then titrate. Titrate the sample with 0.1 m sodium thiosulfate solution with continuous shaking. Add starch indicator toward the end of titration. Toward the end of titration means when the color of titration mixture becomes straw yellow. Continue the titration till the blue color which appears after addition of a starch get disappeared. Note the volume of 0.1 m sodium thiosulfate solution consumed as A. Perform a blank titration omitting the sample and note the volume of 0.1 m sodium thiosulfate solution consumed as A. The iodine value can be determined from the formula. Iodine value is equal to 1.269 into B minus A divided W. Note, if more than half of the available halogen is absorbed, then repeat the test with a smaller quantity of sample. This is all about iodine monochloride method. Iodine monobromide method, which is also called Hanus method. Here again, weigh the sample accurately in iodine flask. Here also the weight of sample depend upon the presumed iodine value. If the presumed iodine value of the sample is more than 100, then the quantity of sample required is 100 to 150 mg. If it is less than 100, that is between 61 to 100, then the sample of quantity required is 150 to 250 mg. If the presumed iodine value of the sample is below 61, that is between 21 to 60, then the sample of quantity required is 250 to 500 mg. And if it is less than 20, then the sample of quantity required is 1 gram. So first of all, weigh the sample accurately in iodine flask. Add chloroform 15 ml and dissolve. Now add iodine monochloride solution 25 ml slowly from a burette. Insert the stopper and allow to stand in a dark for 30 minutes, shaking frequently. Now add potassium iodide solution 10 ml and water 100 ml. And then titrate with 0.1 m sodium thiosulfate solution using a starch indicator added toward the end of titration. Note the volume ml of titrant, that is sodium thiosulfate, consumed as A and perform a blind titration and note the volume of solution consumed here V. Now calculate the iodine value from the same formula, that is iodine value is equal to 1.269 into B minus A divided W. Coming to the determination of iodine value by pyridine bromide method. Here, first of all, weigh the sample accurately in dry iodine flask. Here, the weight of sample is equal to expected iodine value divided 12.5. To the sample, add carbon tetrachloride 10 ml and dissolve. Then add pyridine bromide solution 25 ml and allow to stand in a dark for 10 minutes. Add potassium iodide solution 15 ml in the cup top of iodine flask and carefully remove the stopper. Rinse the stopper and side of the flask with water 100 ml. Shake the titration mixture and titrate with 0.1 m sodium thiosulfate solution with continuous shaking using starch solution added toward the end of titration. Note the volume of sodium thiosulfate solution consumed and as A. Perform a blind titration and note the volume as B. Use the same formula for the determination of iodine value. But if more than half of the halogen is consumed, repeat the process with a smaller quantity of sample. Coming to the pyridine bromide solution, the formula for the preparation of 100 ml of pyridine bromide solution is bromine 8 gram, pyridine 8 gram, sulfuric acid 10 gram and glacial acetic acid QS 200 ml. First of all, dissolve 8 gram of pyridine and 10 gram of sulfuric acid in 20 ml of glacial acetic acid. Keep the reaction mixture cool and then add 8 gram of bromine dissolved in 20 ml of glacial acetic acid. Dissolve the solution 200 ml with glacial acetic acid.